All right. So today, what we'll be seeing is about the redo log management, how to manage the redo logs. In the last class, we saw how to manage the control file, how to create a duplicate of a control file, and how to take a backup of the control file, how to check the contents of the control file, etc. So today is about the redo logs. So what basically do we mean by redo log is, so whenever there is a change in the database, so those changes which happen on the database that is recorded in a location, so that we can use those changes to redo that changes to the block. Say for some reason, if the database crashes and the changes which happened, those are not able to commit. So this redo log will have that information in that log file, which can be used to do those changes again, instead of we asking the user to redo the changes. For example, if there is a bank transaction going on, you are transferring some money from a checking account to a savings account, or you are withdrawing some money. Suddenly, if the database crashes for some reason, and you were halfway through the transaction or you completed the transaction, but when the database comes up, you don't see the transaction happen, then it's a discomfort for the customer, the bank customer, right? So to in order to avoid such kind of scenarios, before the database can open completely after a crash, right? So always it checks the SCN of the control file and the SCN of the data files. So if these two SCNs match, then it will open the database for us. Now, if the SCN of the data file does not match to that of a control file, say for example, if the SCN of the control file is 1000 and data file is 999, so this is a mismatch. Even one SCN mismatch is a mismatch. It will not let you open the database. So in this case, what we generally do is, you might end up in the scenario very few times, but when you end up in the scenario, that means your database has crashed, your company is out of business, and you have to bring up the database as soon as possible. In the situation, you have to recover the database. We will be seeing how to recover a database in later chapters. But when you do a recover of the database, what the database will do is, it will go and check the redo log file to find the changes to make this SCN to 1000. So once it finds the change in the redo log file, it applies those changes to the data file, and then it will open the database. If it sees this difference, it is going to complain to you that I need more recovery. So when you see that information, like error like I need more recovery, you will not understand it at the first go. But again, every error you get, it's more of self-explanatory. Just you need to think in terms of the database is a machine which does not do anything by itself. You have to give it some commands to do that stuff. If you give that command, it will do it, but just you have to give that command. So what command to give, what it is asking for, is what is where your thinking power comes into picture, right? So for this kind of scenario, the changes will be there in the online redo logs, and those are applied. So that is where your redo logs come into picture. Right. So redo logs, generally we how we store redo logs is in three different files. Minimum, it is required to have two files, but it's always better to have three files. Why we need three files? So this log writer process, which is basically writing those changes from the redo log buffer to the online redo logs, those log writer will first go and write into the first online redo log. Say for example, let us consider these are our three online redo logs. So log writer first came and wrote into this redo log 1, redo log 2, and redo log 3. Okay, so log writer first came and wrote into the online redo log 1. So say for example, it wrote something called as ABC. I'll show you how exactly the entries are populated in Redulog. But for example, just let's say it wrote some change information like ABC. Then it wrote XYZ. Then it wrote MNO, PQR, and DEF. Okay. Now it wrote this one. So this Redulog is full. Now, since this redo log information is required for recovery, so it is not going to just go and dump that, go and start writing in this first location. So what it will do is it will go to the next redo log. Next redo log, it will start writing something. Okay, so let's see it wrote same way, many entries over here, and the second redo log is also full. Now, if by chance you have enabled something called as a archive log mode, then what happens is while redo log log writer is writing in the second redo log, a copy of this first redo log is made so that we can save that information for a longer time. If this one is not made a copy, when it completes writing the redo log 3, log writer will come and write this redo log 1. Okay, so that means if your database is not so important, you are just doing some testing activities on a database, or it's a development database where not much information needs to be stored, you might not need recovery of this database, then the database is not there in archive log mode. Now, why will somebody not want to put the database in archive log mode? To save some storage space, right? Because this, if this redo log is say of 100 MB size each, so every time it makes a copy of this one, it creates a file of 100 MB. Okay, so in one routine of redo log writing this one, it will create 300 MB of files if archive log mode is enabled. Now 300 MB of file can be created probably in 1 minute depending on how busy the database is. Now if 1 minute you are generating 3 MB of files, 60 minutes you will be generating around 180 GB of files. So this is a lot of space on the storage. So to avoid this kind of space usage in development databases or testing databases, they will not enable archive log mode. So coming back to the point where read log writes this one. So for the time being, so that we can have that redo log information for probably a few minutes, that's why we give more number of redo logs. Now 3 is kind of the default which is recommended. It is always better to keep 3, but you can keep more than 3 also. Okay, so these are called as redo log members, right? Redo log 1, redo log 2, redo log 3 are called the members. So multiple copies of, no, not multiple copies, multiple redo log files are created. Okay. Now what all information does this redo log have? So in redo log, what happens is the changes are saved in something called as a change vector. When I say change vector, it is just a set of numbers which the database understands. But there is a way we can decrypt those data for our understanding. We'll see that later. But it basically puts a set of numbers. For example, just to put that set of numbers in this one, 01, 02, 03, 09, 0A, A9, something like the set of numbers it will have in change vector. So if we consider each cell in this Excel sheet has a space for saving one change vector, you will see some entries something like this. Okay, it keeps on changing. Okay, it's not necessary that it has to be same. So these entries keep on changing. Basically what this information means is what was changed on the database level, which block was changed, at what SCN it was changed, and what change happened on that one. So that kind of information goes into this binary string which is over here, or hexadecimal string which is showed over here. Where is that? Okay, so a group of change vectors are stored in the redo logs. Okay, so this redo entries are basically used to reconstruct the changes made to the database, just in case if you end up in a scenario where the database has crashed. Now, other than that, what all other information we stored in redo logs is, it's basically also has the SCN number when the changes had happened. Okay, every redo log has something called as a low SCN and a high SCN. So what exactly we mean by low SCN and high SCN is basically the SCN number when this particular redo log was started to populate. That will be the low SCN, and the SCN number where this redo log writing stopped because it was full will be the high SCN. So every redo log will have a range of changes in it, and that is tracked by the SCN numbers. Now SCN, what is an SCN? System change identifier. It's like a clock for the database. So that number is keep on incrementing. It's like a clock, every second it's running, right? So that number is keep on incrementing, and for every change number, what changes was made, it's written into the redo log. So those changes are accumulated here, 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 and when that redo log is full, change number is written over here, and that is considered as a high SCN. And the redo log, when this entry started, will be considered as a low SCN. So we will be this SCN numbers will be helpful when we come to a recovery part of the database. We will see why these SCNs are so important. Then you will see that database is asking for a specific SCN, and how do we find that SCN is by querying some of the views of the redo log. Say for example, when you are doing a recovery and database said I want a change of SCN 105. Right. Now, how do you know which redo log or which archive log has this SCN? So there are few tables or views where that information will be stored. So you go there, you find out which particular redo log has this information, and you give that location of that redo log, and that utility will recover the database from those changes. So it has low SCN, high SCN, and information of all the other transactions. Just for an example, this is how the information will show up in your redo log if you really try to get a dump of that uh, redo log. So here basically what all it's showing is, this is basically the header of the redo log. So all this information will be there, but we have not yet uh, dumped the data for the contents of the redo log, but the data will also be something similar to this one. So here you will see few easy things to show you. The version of the database is put. This is the version of the database. It stores in a language which is called as a hexadecimal. In hexadecimal, how things are represented is, um, so for numbers, we go from 1 to 9. It goes until 9, and after 9 we start writing as a B C D E F. So this is how the number is the what do we say, the information is represented in the hexadecimal. So this is hexadecimal. Similar thing in decimal would be like this. So this will remain same, 1 to 9. In decimal, the normal way which we use, it will be 10, 11, 12, 13, 14, 15. Okay, in decimal language, which we generally use for numbers, it is this is how the numbers are identified. But when it comes to hexadecimal, until 9 it will come, then A, B, C, D, E, F will come in the hexadecimal. So if you see this screenshot, remembering that one, here 0A means number 10, 3A means 3 followed by 10. So that is how it is converted by the machine, right? So all that information is stored in this way. Control file sequence, this is the file number which was changed, and This is the type of the file. This is the low SCN, next SCN, enabled, when was the SCN enabled, all that information is done. Now, this is not required for you to remember. This is something a high level thing. If such kind of thing comes in your DBA support life, then that means that you are already talking to somebody in Oracle support and they are trying to decipher the redo logs for you to determine some issue. As a DBA, you will not be working at this number level. I just wanted to show you how this information is stored. So this is how the information will be there in the online data logs. It's at the machine level, only machine will understand this one. But for our understanding, this is how it is. Again, log writer keeps on writing in a cyclic way. Once it starts writing on the third one, it will go again to the first one and write the first online data log. So this kind of use is called as a circular use. It keeps on circularly using the online data logs.
So, I mean, will it get corrupt or something like that? Redo log file
Yeah,
at
redo
some
log
point?
file will get corrupt. There is a possibility that redo log file is will also get corrupt. In that case, when redo log file is corrupt, there is no other way to get back the redo log unless you have made multiple copies of the online data log, which is nothing but you have made a multiplexing of online data logs. Like we did the multiplexing of control file, there is an
Hmm.
option to do the multiplexing of online data logs also.
So,
So
is it like required, like you do it like every?
it's always better to have multiplexing of everything, control file, read log file, and control file and redo log file, two things. It's always better to have it multiplexed so that if just in case one copy gets corrupted, you have another copy. One copy gets lost, you have another copy. Always these two things, always multiplex it.
And you keep it on the same server, like, or you
Server,
can.
yeah, it will be on the same server only. We cannot go from one server to another server,
Okay.
but it will be on a different file system,
Okay.
like C drive, D drive kind of
Mm. Okay.
option, right? So
Mm.
one you will keep in C drive, another copy you will keep in D drive, because
Mm.
just in case if C drive is corrupted or messed up, then you have that same information available in D drive.
Mm.
So same kind of concept. Okay. Now, I'll come to the archiving later on. We have a separate chapter for that. Now, multiplexing of read logs. You just now asked for the about the corruption, right? So, multiplexing of read log is basically making identical copies of the online read logs. Now, let us see in my database what are my online read log locations. So, there are two views for which give us the information about online data logs. First one is v dollar log, easy online data log, v dollar log. Okay, so this one will give me the group number, thread number, sequence number, what is the size of the redo log, and how many members are there in each group, and whether that one is archived or not. What is the status of the online redo log? What is the first change number in the online redo log? What is the next one change number? And what was the time this change happened? Okay, so this is one view. There is another view which is called as v dollar uh, redo. No, just a minute. Okay, v dollar log file. Okay, this also gives some similar information, but this gives us the name of the online redo log file. Where is it located? So when I do select star from v dollar log file, it will give me information of all the redo logs which I have. Let me set the size. So here, if you see, right, this information it dumped in multiple lines, which is a little bit confusing. because SQL Plus reserves only so much of space. Whatever you see here line, only it reserves only so much of space to display your output. But if you do this set pages and set lines, means you are telling the SQL Plus you can use 1,000 pages and 1,000 as you can say you can use the page size for 1,000 characters and lines down like number of lines 1,000 lines. So when I run that same query again, I have that information in kind of one line. Still it is kind of going to the second line. That is fine because this particular uh, entry is very long, that's why. Okay, so here I have three groups of online redo logs. One, two, three, which is default. And where are they located? They are located, all three are located in the same location. You see here, this location is same. Okay. And I have named the redo logs to redo01.log, redo02.log, redo03.log. It is always better to name them with actual names what they are for, so that any DBA, any junior DBA, senior DBA, whoever is trying to do some cleanup, they do not accidentally delete the files which are required. I have seen cases where people go and delete the redo logs, and then they have the database in danger and they don't have information to start the database. But it's always better to understand that system, whatever database you're working on. Simple query, select star from v dollar log file will give you all the information. So what I generally do after my what I used to do is after my first or second project, when I gained this knowledge of like these files are very important, we should not touch or delete these files. I used to log into the database, pull out this information and keep it handy, so that if anytime I am doing a cleanup, I avoid these locations. I don't go these locations. I don't delete anything in these locations, because when you are in a hurry to clean up space so that database does not freeze, then is when you make the mistakes. So always try to be think ahead of time and keep things handy so that you don't need to panic around that time. Okay, so these are my three online data log files. So here I have not done multiplexing, because if you see, all the three online data logs are basically in the same location. Now if I want to do multiplexing, how do I do multiplexing? Is basically create more groups of the online data log. So what happens is, right now if I say this one is my what was the name, redo 01, right? Redo 01, redo 02, redo 03. So if I'm multiplexing, I can name this one as redo 101. Okay, redo 201. Sorry, what we'll do is redo 102, redo 103. So what happens is, when it is trying to write the information in the redo log, when log writer is trying to write the information in the redo log and you have multiplexed the redo log, what it does is it writes in redo 01 and it writes in redo 101 at the same time. So you don't need to worry about copying the files, the entries which is there in redo log, right, when multiplexing is done. Now this one is written both together and overwritten both together. If you want to make a copy of this guys for a longer time, more than the time which can be taken to replace these entries, then the archive redo log will come into picture. Multiplexing is different, archiving is different. All right. So multiplexing is just that you want to skip any issues just because the redo logs are deleted or redo logs are corrupted. That is where your multiplexing will come into picture for your help. Okay. So while redo 01 is writing, redo 101 is writing. If you created a third group also, then this one redo 201 also will be writing at the same time. Okay, then when it jumps to the next one, for the next redo log, it will write redo 02, redo 102, redo 202. Again, when it jumps, redo 03, 103, and uh, 203. So all members depend belonging to the third set will be written same time, second set will same time, first set the same time. Okay, so that automatically happens. We don't need to do anything, just that we have to set up the multiplexing. So how do we set up multiplexing? These are the commands which you can use to do the multiplexing. So I'll just copy this command and I'll show you how. So these are similar commands. You can find this in Google also, how to multiplex online data logs. So here you see my group number is 1, 2, and 3. So I have to have a group number, a different. So what we are going to do is we are going to add a member to same group. So group 1, I am going to add a member. So what I will do is alter database, add, not this one. This is while creating both together. Since I already have a group, I'm just going to add a member. So this is my current location. What I will do is I will add a new redo log in this location. And I'll name it redo101.log. Okay. To which group I want to add? Group 1. So just copy this and in SQL Plus only, just paste it. It is basically, it says database altered. Now if I run that same command again, select star from $log file, it is giving me a new member. Now it is saying this is invalid, basically because this is not yet being used. Okay, so what I will do is, let's first check if this one is created. I'll exit of SQL Plus and I'll do ls and they give this location. So this file exists. Okay, this file exists. Okay, so this is the size of the file. This is the date when the last time this file was touched. Okay, so this is how we add members to the online redo logs. Now since I added for one, I have to add for others also. So I'll say group 2 and this one is 102. The same thing for group 3. So if you add a member to one group, you have to add it to the remaining groups also. You cannot have just one group multiplexed. All three have to be multiplexed at the same time. Okay. So the new ones are showing invalid. That is fine. And the total, if you see, now it's 6 rows. Okay. Every time you get out of SQL Plus, this setting will change. There is no way to kind of standardize the settings. So group 1, 2, group 2, 1 and 2, group 3. Okay. So when it is writing to one particular online redo log, right? Say it is writing to online redo log 1. Now if you want it to jump to the next redo log, you can force it to do that one. It will just finish writing this redo log in half the time in at that particular spot it is writing, and it jumps starts writing to the second redo log. How do we force that one to happen? Alter system switch log file. So when we say this command alter system switch log file, basically it stops writing on the redo log which it is currently writing. It might be 1, 2, or 3, wherever it's writing, and it jumps to the next online redo log. Okay. See, now 1 became valid because it has started writing to redo log 1. Okay. Now if you want to find out, I'll just run that switch command 3 times so that all redo logs become valid. So all are valid now, no problem. So now if you want to see which one is currently being written, the other $log will be helpful. So in this one, select, we can put star itself, let's say how much information we get, $log. So here you see group 1 of thread 1, don't worry about this thread, it's basically instance number. The sequence number for this one is 25. Now this is sequence number, not SCN number, okay? System change number, not a system change number. This is sequence. Every redo log will get one sequence number. Okay. What is the size of the online redo log file? You see here the status here. If the status here says current, that means it is currently writing the redo log 3. When I do a alter system switch log file and I run this command again, you will see now the current is redo log 1 and this is active. Active in the sense it has entries and it can be converted into the archive log file. That is what active means. And inactive means this one does not have any entry and you can start writing again. So if I do this again, then it will, the current will jump to the next one. See, now 2 is current. So currently it's writing into the redo log 2. And you see the sequence, it was just 25, 26, 27. Once I did a switch, this became sequence 28. 25 became 28. So basically 25, 26, 27, when I did a switch, it came here, it started a new sequence. So all that content which goes into one redo log is marked with the sequence number. That is what it keeps on changing. Now next become 29. If I again switches, this will become 30. So that keeps on changing and rotating. Okay. So that is about how the online redo logs are managed and how to multiplex the online redo logs. We will pause this here and join back.